The learning goals for this lesson are to apply arc length, sector area, angular velocity, and linear velocity to real-life situations. Number 1, Tan is driving in a circle. The circle is 5 miles around. So the circumference is 5 miles. And they have traveled 1.5 miles of the circle. So the distance traveled is 1.5 miles. What fraction of one rotation have they completed? Well, if the whole rotation is 5 miles, I can take 1.5 and divide it by 5. I might change that to 15 divided by 50 by moving each decimal one time to the right. Then reducing those by dividing by 5, I would end up with 3 and 10. They have completed 3/10 of a rotation. Letter B. What is the angle of rotation completed? If we do this in degrees, there's 360 degrees in a circle, and they have done 3/10 of the circle. I can put the 360 over 1, and then I can divide 360 and 10 both by 10, giving me 36 times 3. And 36 times 3 is 108. The angle of rotation is 108 degrees. A clock has a minute and an hour hand. Chi-Hua looks at the clock at 9:35 and 9:45. A. What was the angle of rotation for the minute hand? We have a clock. The minute hand used to be at 35 and now it's at 45. It has traveled 10 minutes. 10 minutes out of 160 minutes in an hour. So it has traveled 1/6 of the circle. The angle of rotation would be 360 degrees multiplied with 1/6, or 60 degrees. Oops, sorry. If we did this in radians, radians is 2 pi, and we had traveled 1/6 of the circle. Reducing down to pi over 6, it would become pi over 3, which shouldn't surprise us as 60 degrees is a memorized pi over 3. What was the angle of rotation for the hour hand? Up first, someone might say it's 0 degrees, but we have to remember an hour hand that is at 9 o'clock and 35 minutes is going to be almost halfway in between 9 and 10. And then at 9:45 is going to be even closer to 10. So we know that there are 12 hours in one rotation. And every hour is 60 minutes. So that means that there are 360 minutes in one rotation. From 9:35 to 9:45, there has been a 10 minutes have gone by. So 10 minutes out of one rotation, which is 360 minutes in a 12-hour rotation, is equal to 1/36 of the circle. But we have 360 degrees in a circle, and 1/36 of that is 10 degrees. So it has rotated 10 degrees. Now let's take a look at the area of the shaded section. That's the blue section. We have to imagine that there are 2 circles here. Sorry for my circles. So there's the large circle and there's the small circle. All right, let's find the area of the large circle. area large. We know area of a circle is pi r squared, and the radius is 15, which would be 225 pi. Then the area of the small circle, which is the white one, is going to be pi times its radius squared, 49 pi. But we have a 60-degree angle. So this is a sector, and we are going to take the area of the large sector, I'll call it LS for large sector, and that is 60 degrees out of 360, multiplied with the area of 225 pi. All right, 60 over 360 will reduce down, the zeros reduce, and the 6 over 36 will become 1/6. So we're doing 1/6 of 225 pi. And I'll leave it like that just because. Then the area of the small circle, and we only want a sector of it. Like before, it's going to be 60 over 360, and I know that reduces down to 1/6. And it is of its area, which is 49 pi. Now I need to subtract these two to get the area of the blue. So the area of the blue is equal to the area of the large sector minus the area of the small sector, and those will equal 1/6 times 225 pi minus 1/6 times 49 pi. Oh, I'll factor out the 1/6 for now, and that gives me 225 pi minus 49 pi. 225 minus 49 is 176 pi. If I take 176 and divide it by 6, I will get a decimal. So changing that back to a fraction. That did not like me. I divided it by 2, and I got, or divided 176 by 2, I got 88 over 3 pi. So that is the area of the blue section. Now earlier when I said sector, what I mean is that if I had this entire pi wedge, that's called a sector. And that is the large sector, and then this would have been the small sector. All right, so arc length, just as a reminder, arc length is the distance around a circle. Distance around a circle is known as circumference. So circumference is 2 pi r, also known as pi d. But if I want arc length, which is notated s, then I would want the fraction of the circle that I'm working with. And I would multiply it by the circumference. An area, you know, is pi r squared. But if I'm wanting the area of a sector, then I use that fraction of the circle and multiply it by pi r squared. All right, now we're going to take a look at the words of speed and velocity. Feel free to try and do these problems on your own for a little bit and then come back to this video if you need to. So speed is how fast something moves, while velocity is speed but direction that is connected to it. For example, if a dog runs 9 kilometers per hour, that's his speed. It doesn't tell us what direction. But if a dog runs 9 kilometers per hour northwest, then it turns into velocity. And so a little science lesson there. Problem 1. Kaylee is driving 37 miles per hour on Wine Country Road for 3 minutes. What distance has been covered? All right, we can do a little quantitative analysis. 37 miles per hour. But she is only driving for 3 minutes. We know in 1 hour, there are 60 minutes. And then she is driving 3 minutes. If I multiply straight across, I get 37 times 3, 111. And the label at that point, if I cross things off, hours cross off, minutes cross off, I would have miles. And I'd be dividing that by 60 on my calculator. I get that this is equal to 1.8, sorry, keep hitting this on the bottom, 1.85 miles. Right, now Dominic drives 210 miles for 2 hours and 45 minutes. What is his speed? If Dominic was driving from Pasco to Spokane, what was his velocity? Let's first figure out his speed. We know distance equals rate times time. So we're essentially trying to find the rate. And distance divided by time will give us his rate. So Dominic drove 210 miles, and his time was 2 hours and 45 minutes, which is 2.75 hours. If we divide this, we will have his speed, which is about 76.364 miles per hour. That is his speed. To turn it into velocity, we want to think about the direction from Pasco to Spokane. With a map of Washington, it's going to be a rough map of Washington. We have Pasco down here, and we have Spokane about right there. So we can say that we need to go north, but we also need to go east. So we're going to go northeast. We need to go north, and we need to go east. So we are going northeast. And his velocity then is 76.364 miles per hour northeast. At this point with number 3, I'm going to stop and I am going to work it out, and then you can check yourself. Since the diameter is 24, the distance around the wheel is 24 pi. I drew that picture, diameter, distance around is 24 pi. Now if I draw out the circular part all the way around the circle, that is really a straight line if we unrolled it, and that would be 24 pi, or about 75.398 inches. So I took 3 of those segments roughly, and each segment is 24 pi, making it a total distance of 74 pi. Or sorry, 72 pi. And if the wheel rotates 3 times in 5 seconds, how many rotations are accomplished in 1 minute? There are 3 rotations in 5 seconds. There are 60 seconds in 1 minute. Another way to look at that is that 60 divided by 5 is 12 groups of 5 seconds. So 3 rotations times 12 groups of 5 seconds is 36 rotations. So in 1 minute, if there are 36 rotations, and each rotation is 24 pi, multiplying those together, I get 864 pi inches are covered in 1 minute. That means the linear velocity is 864 pi inches per minute. All right, I'm going to pause there, and the merry-go-round I will do in a separate video.